In this particular video, we are going to discuss what is reliability, how to define reliability, mathematical expression of reliability, and then explaining reliability with the help of a real life example. Reliability is defined as the probability that a product, system, or service will perform its intended function satisfactorily for a specific period of time under a specified operating condition. In this definition, you need to remember certain terms like probability, perform intended function, satisfactorily, specified period of time, and specified operating condition. Now, here probability means the likelihood that the system, product, or the service will perform their intended action successfully, right? Now, what is intended function? Intended function is the reason why the product, system, or service is there in first place. Let's understand with the example of a washing machine. So suppose you have bought a washing machine, right? So what is the intended function of the washing machine? The intended function of the washing machine is to wash clothes. To be more specific, we can write that the intended function of the washing machine is to wash minimum 6 kgs of clothes and dry it out within 45 minutes. So that can be one of the intended function, right? And the probability is the number of times you operate the washing machine, how many times it will be operating properly without any problem. Now, satisfactorily means every product comes with some specification, right? It will say it will dry the cloths to a certain degree, or it can wash up to certain amount of weight. So these are the satisfactory level. So if you are putting less amount of cloths or the equal amount of cloth, it should work. But there is no guarantee that if you put higher amount of cloth, it will still work. Then specific period of time. What is meant by that? Every machine is designed for a life, right? A machine cannot uh, work, for infinity, right? It will work for a specified period of time. For example, the washing machine may work, say, 10 years. After 10 years, the manufacturer cannot guarantee its performance. So the reliability is also dependent on the time. Then specific condition. Every machine or product or system or service is designed to work under a specified operating condition. For example, the washing machine will work at 50 Hz 240 volt AC supply, right? That is the one of the operating condition. Now, if you give the same machine 110 volt AC and 50 Hz supply, it will not work, right? Similarly, uh, if there is a electronic compound, it will work until 50 degrees centigrade. But if you take the same mobile, say in the desert, and where the temperature goes maybe up to 70 degrees centigrade, if you try to work it out, it will not work. So reliability is basically always dependent on these five factors. And when we are reading a reliability of any product, system, or service, we should always read the reliability with this context. Now, mathematically, reliability is expressed as a function of time, right? And the expression is RT is equal to e to the power lambda t. Now you see, when the t is equal to 0, RT becomes 1. And when the t tends to infinity, the RT becomes 0. Right? At any time between the 0 and infinity by putting the value of the t. From this equation you can get the RT value. Now every product, as we told you, has an operating time, right? So the reliability concept holds true within this operating time. Outside the operating zone, this RT function may work differently. So if there is a machine whose operating time is defined as 10 years, then from 0 to 10 years of time period, you can use this equation RT is equal to e to the power lambda t, and you can get what is the reliability value at any point of time by using this graph. But beyond 10 years, this particular reliability equation does not hold true. Now take a practical example. There is a pump and the manufacturer of the pump has specified the operating time of the machine as 10 years and the reliability of the machine on the 10th year is 0.8. Then what will be the reliability of the machine in the 5th year? So as we know that this year 5 is between its operating years, so we can use the equation RT is equal to e to the power lambda t. Now there are two unknowns here, that is lambda and RT. Both are unknown. But we know one thing, that R10 is equal to e to the power lambda 10. Right? So from this equation, we need to derive the value of lambda. Right? And then we need to put this lambda value here in the 5-year equation of lambda 5. And from that, you can get R5. Hope this is clear to you. So please comment in the chat box what is the R5 value you are getting for this particular example.